In this video, I'll be going over question 18, which says, let f and g be permutations on A. Prove that the inverse of f of g equals inverse g of inverse f. To clarify, f of g means the function f of the function g of x. As I looked over this question, I found it hard to find a good way to prove this to be true. But then I remembered something from a few classes ago, where some of the other students pretty much used examples to prove their points. And that's what I'm going to do in this video. First, I chose two different functions for f and g. For f, I chose the square root of x, and for g, I chose x minus 7. So when I plugged in the two functions, I got square root of x minus 7. Now that I knew that was my f of g function, I substituted y for f of g, and then switched the two variables around to conclude that the inverse of f of g is x squared plus 7. Next, I took the two functions individually and found their individual inverses, and I concluded that the inverse of f is x squared, and the inverse of g is x plus 7. Once I had all my inverse functions found out, I had to figure out which order of the two inverses would work to match the inverse of the two functions together. Was it inverse f of inverse g, or inverse g of inverse f? I had to remember that inverse f was x squared, and inverse g was x plus 7, so choosing which one to substitute for the other would change the outcome. So I started with inverse f of inverse g, which meant I had to substitute x plus 7 for x, which meant I got x plus 7 all squared. And when distributed out, that did not equal x squared plus 7, which gave me the option of inverse g of inverse f. And all I had to do for that was substitute x squared for x, and sure enough, it gave me x squared plus 7, which is the inverse of the two functions combined. This meant that the order inverse g of inverse f was the correct order and matched the inverse of the two functions, thereby proving that the inverse of f of g equals inverse g of inverse f.